For this experiment, you're going to be investigating a couple of different things. One thing that you'll be investigating is the metal reactivity series. The metal reactivity series, also known as the activity series, is one way that you can look at the ease at which a metal loses an ion and therefore is oxidized. For instance, lithium. Lithium, with the atomic symbol Li, is a substance that very easily is oxidized and very easily oxidizes, loses an electron, and forms the lithium plus 1 ion. Okay. For this experiment, what you're going to be doing is you're going to be looking at a total of 3 different solutions. You'll be looking at zinc chloride, copper chloride, and nickel sulfate. You will be looking at those solutions compared to how reactive they are with 3 metals. Those metals are zinc, copper, and tin. Now, it's up to you, based on the activity or the reaction observed with those 3 metals with these 3 different solutions, to identify which metal is which. Now, these 3 metals will be labeled as metal A, metal B, and metal C. So you'll have to look at how they react with these different solutions and, based on that, determine, well, which is which. The second part of this experiment will be looking at precipitating a solid. You'll be using a solution of sodium hydroxide, or NaOH, and a solution of copper sulfate. Those 2 solutions are both soluble, and those are both going to completely ionize in solution. So when you mix those 2 separate solutions together, well then, the sodium ion and hydroxide ion will come in contact with a copper ion and a sulfate ion. Now, what's going to happen when those interactions take place is copper and hydroxide, those will form an insoluble solid, a precipitate. Now, what you're going to do is you're going to recover that precipitate and then ultimately determine how much of that precipitate you actually recovered. Now, if you watch the next few videos, I'll walk you through all of that.
Here's our bin. Here's our well plate. Here's our card. Overlay of the well plate on the card. My transfer pipette is filled all the way. Drop, drop, drop. I would say that's about a little bit more than a milliliter into each one of them. So that's 3 milliliters. This marking right here is 3 milliliters. So I got about 1 milliliter of each solution into there. I've got about 3 milliliters of my nickel sulfate solution, 1 milliliter into each one of these. We are good. Last but certainly not least, the copper chloride solution. There we go. We've got our 3 solutions lined up. Perfect. The colors match and everything like that. The last solution that I needed to get for my plate was water. So I've added water to D1, D2, D3. That's going to serve as a control, a negative control, in fact. I have my 4 pieces of my metal A. I'm going to drop into each one of these solutions. Oh wow, look at that. Immediately, something happens whenever I put it into the copper solution. Okay, now let's take a quick glance at everything else. Nothing there, nothing really appearing to happen there, but that's definitely something. Okay, so next up, I've got these 4 pieces of metal. This is metal B, or unknown number 2. Okay, so I'm going to put drops of this into each solution. That's metal B in water. Nothing really happening there. B in the copper chloride, nickel sulfate, and the zinc solution. Okay, now A. Well, it looks like A might be reacting in that nickel solution. See those little black specks there? That might be something kind of materializing. Oh, wow. Okay. Now we've got our 4th metal into each of our solutions.
So as you can see here, the reaction of your different metals with your solutions varies a little bit. Metal A seems to be reacting in the nickel and the copper solution. Metal B is kind of reacting only in that copper solution. None of them are reacting in water.
I'm going to get my sodium hydroxide solution now, and there we have it. 25 milliliters of sodium hydroxide. 25 milliliters of a copper sulfate solution. So now in my two solutions, my sodium hydroxide and my 25 milliliters of
Copper sulfate.
what happens whenever I transfer one of them together. Oh wow. That was something else right there. Okay. Let's try to recover this. We're going to set up a gravity filtration apparatus. And the way that we're going to set that up is by taking this funnel and placing it onto that Erlenmeyer flask. Next, we're going to take that coffee filter and we're going to rip
The edges off of it.
what's the mass of our coffee filter. What's the mass of our watch glass?
The last thing that you need to do with respect to your materials from this lab is you need to throw your filter paper and the copper hydroxide that you precipitated, you need to throw that into the solid waste container. I showed you that you need to spray down your well plate with ethanol. Do that with all of your other pieces of glassware to ensure that they are dry before putting them in your bin. Now, with respect to finishing this experiment, what you need to do is you need to go ahead and complete the calculations for percent error so that you can figure out how accurate or inaccurate your results were. One of the things that's probably going to influence your results is the amount of water that persisted in the coffee filter. So that's definitely going to influence your results. All right. Well, I hope that was helpful. I hope you were able to visualize a precipitation reaction and work through ionic and net ionic reactions. All right. Have a good one.